Alright, this is just a great little problem, and I'm going to actually do it with wires in two different colors to demonstrate. So I'm going to say this is wire 1, and this is wire 2. And here's the idea. When we look at the right-hand rule for wires carrying current, this wire puts out a bunch of magnetic fields lines going into the page right here, meaning those lines physically point, it's as though they're pointing into your screen. So what does that tell me? When I use the right hand IL cross B rule on the purple wire, what I see is using the right hand rule. So with the right hand rule, I end up getting that the force points to the left. Similarly, when I look at the field lines put out by the purple wire, and I want to be really clear, yes, the field lines, you might think, well, they cancel each other. They have a very peculiar property, which is that these X's can't affect the blue wire itself. Okay, only the purple ones can. So it's like a Newton's third law thing where this feels a force in the blue feels a force in the purple. So when we actually do a similar right-hand rule on the blue wire, what we find is that the force on it is to the right. So this is the force on the blue due to the purple, and this is the force on the purple due to the blue. That's how those two forces work. Okay. So that kind of shows us. So you need to show me that using the right-hand rule. Now let's calculate the force. So by Newton's third law, the forces are equal and opposite, so we only need one force. So let's go ahead and do that now. First, we need let's actually calculate the force on the blue dude from the purple dude. So we're going to calculate the force on the blue dude due to the purple dude. What that means is that we need I times L times the B due to the purple wire. So B due to the purple wire is going to be mu naught I over 2 pi r, where r is this distance here, and that's 1 meter. So we're going to have 4 pi times 10 to the negative 7th times my current, which is 2 amps, divided by 2 pi times a distance, which is 1. So the pi's cancel, we get the 2's canceling. So it looks like we end up getting a magnetic field of 4 times 10 to the negative 7th Teslas. So now we can use that in the calculation here. So we're going to end up getting I on the first wire, which is also 2 amps. They carry the same current. L is 3 meters. We're told that B is 4 times 10 to the negative 7th. So what we end up getting is 24 times 10 to the negative 7th, or if you prefer, 2.4 times 10 to the negative 6th newtons of force on the wire. So that is the answer to number 6 on the practice test. Hope this was helpful, and I'll put this on YouTube now.